Dear viewers, in this video we will see how to make such kind of 2D drawings from the part model and assembly using Solidworks. So we will take this flange coupling exercise. So I'm going to make 2D drawings. So I already have a video on my channel how to make part modeling and assembly for this flange coupling. So I will share the link in the description box. If you want, you can go and watch that and come. And then now we'll start with this 2D drawing of this flange coupling. Open SolidWorks and click on this new open drawing module. Click OK. So first thing is it will ask you to select a standard paper size, standard format for putting the 2D diagram. So here you can see a lot of default formats, standard formats are available. So you can select any one of this based on your requirement. So I'm having my own key based on my requirement. So I will put a separate video how to make a sheet based on our requirement. Okay, in a separate video I will post it. Okay, this is my sheet. Okay, so here I only have three boxes, one register number. So this is I'm taking classes for second year students, so I designed this accordingly, the title, and then this first angle of projection symbol, and here you can have a college name, a scale 1:1, and all dimensions are in okay. So now I will bring parts. Each part, the first part is flange. Okay, browse. So select the flange, open. So automatically you will get a view. Okay, so this is front view. So I'm going to have this on the right. Okay. So if you take here, you can see this is coming to the left. Okay, so first you place it, then later you can click and you can change the position. Okay, just click on that object and just move the mouse so that you can change the position. So check the scale first. Here the scale is 1:5. So I'm going to change to 1:3. So select the object and then give. Okay. So both this view should have same scale. Okay, this 1:3. Then click OK. Now we'll start giving the dimensions. So before dimensions, we have to enable the hidden line option. So select this and select this one. Okay, so now you can see all the hidden edges. Okay, so you have to enable it here. Just select and you have to enable this one. And if you see, you can see there is a center line for this hole. It is a hole. It will having a center line. So, but it is not available here. So go to the annotation and you can see the center line. So select this, select these two lines. Okay, so I got the center lines. And here you can see this pitch circle. This is also not available. So you can use sketch. You can have a circle. And you can put a circle. So after putting the circle, select for construction. Click OK and come out. Okay. Now I have all the entities. Okay, so now I'll start dimensioning. So select go to annotation. So you can see smart dimension. So you can start. Sorry, again select smart dimension. So this is 190, and then this one is again 190. So next thing is can come to this view. So here can give the dimension of this one. Okay. So here they have given see, you can see it is 45 diameter is given, but it is showing the radius. So you want to change to diameter, you can see this a leader type. So go to the leader, so you can see the options. Okay, so this you can select, you can get it as a diameter. Okay, next thing this 140 I have to give. So little bit I will move this one, select, and little bit you move to the right so that you will get space. Okay, so while giving the dimension, two dimensional lines should not intersect on each other. Okay, so select the smart dimension, select this two center lines. So it is 140, but they have mentioned as PC pi 140. So but here we are getting only 140. So how we can control that? By going here, so you can see, select this, you can see this dimension text. So here I keep the cursor and type PC, then see here PC is reflecting here. So next press this pi, so you'll get a PC diameter symbol and then 140. So if you want to control the precision also, you can control. So here they didn't, so after the decimal they didn't have the this decimal zero zeros. Okay, precision also you can control here. Okay, see here, you can select and give none. So automatically it becomes 140. Similarly, you can select this also and give precision none. So wherever you require, you can give. Otherwise, you can switch off the decimal fractions. Okay. So next thing is 47. Okay. So I'll move this one a little bit. So because here we have to have one more thing. This representing this whole plus this keyway. So dimension. Click on these 2 points. So which is 48. But here it is given as 47.9, this with a positive tolerance of 0.2. So the same we can give here also. So here you can see overwrite value. So select this and you can overwrite the value. So I'm giving 47.9. Okay. So 47.9, and then they are having only one precision 47.9, with they are given the positive tolerance. Okay, so here also we can give the tolerance. So here you go and then select this fit with tolerance. So now you can able to define two values. Okay, this so after overriding the value, you can see actual dimension is 48. So you can select this override and you can give the override value, which is 47.9. And they have given a positive tolerance here. You can see 47.9 plus zero point 0.2. So here you can select this one and you can select fit with tolerance. So now you will have the option to specify the tolerance level both in negative as well as positive. So this precision is 1. Okay, the main value precision is 1. Okay, so next you can have this. So here you can enter. Okay, which is point 0.2, point 0.2. Okay, this plus point 0.2. So in negative direction you can take this is 0. Okay, so there is no negative tolerance here, so it is 0. It's point 0.2. Okay, so for a tolerance, yeah, again you have to check the decimal places. So it is also 1. So here you can give same as nominal. Okay, so you can place it like this. So you can see the font size is too high. Okay, so if you want to bring it inside, so you remove this on the same, after selecting this on this, go to others. So here you can reduce the font size also. Fit tolerance font size. This is so I reduced the font height. Okay, so here also you can font size you can reduce. So font height. so that you can reduce, you can change the height and you can check. Okay. So this 47 you can reduce font. So here you can see points or units itself you can give 3. See, now it is within the dimension line. Okay. So while dimensioning, you have to be careful that so the numbers should visible very clearly. Okay, it should not intersect with this dimension line. Okay. The next thing is what is this 20 mm. So smart dimension 20 mm. Again, you can see this 20 mm is I can switch off the precision. You can see it on the left side. So none. Now it become within the dimension line. Similarly, this line and this line. So here also you can remove the precision. Okay. So check what are the dimensions left. Okay, the taper 1:100 that is left. Okay, so for that I am going to take this note. Okay, so you can provide notes also. Taper 1:100. For note you can select this A. Okay, so after that you can adjust the position also. So now this part I completed. Okay, this, so still something is left in here, this view. This 14, that small, so first I'll give that 14. So 14, they have given it outside. Okay, so you can check it here. It is outside 14. They have given it along with the tolerance. Okay, positive tolerance. So the tolerance value is 0.0122 or 0.05. Okay, so here you can give none, so you'll get only 14. Now tolerance precision fit with tolerance. So for tolerance we can go up to 3 decimals, so select 3 decimals. Okay, so now give the value here. So the value is 0.120. Here the value is 0.050. So again we'll check it. Yes, so both are positive. So instead here you can give, okay, so instead of minus, if you give plus, it will reflect here. Okay, in the minus column, so in the minus column you give plus, so it will reflect here. So we'll reduce the size of this tolerance. So you can see the height is very high, so I'm going to give 3. Still, if it seems like you can have 2.5. Yes. Still, what thing is left? Okay, here you have to write this 4 holes pi 12 along with precision on pitch circle diameter 140 equally spaced. So this we will write here. So can select a dimension. So you select this one. So whatever you want to write, whatever you want to add, so that you can add it here. So in this dimension text you can add it here. So 4 holes, so HS caps, so 4 holes, and then comma. The next is 12 mm, it is as it is. Then after followed by on. So here you have to select on and you have to continue writing. What is a PC pi 140 EQ spaced. Okay. PC phi, you can go and select the symbol here, this pi symbol, pi c 50 space EQ spaced. Okay, so it is like coming like this. So here you can see a bend is there. Okay, so if you want to give that bend, So select this one. Okay, go to leaders. So here you can see this bend option. Okay, multi-jog leader. So select this one and go close to this line. You can see that there is a change in the symbol. When you come close to this line, you can see there is a change in the arrow mark. Okay, so that means wherever you want to give a bend, so you click, go close to that point, right click, and you can see add jog point. So here you can see add jog point. So now a jog point is added here. So now just click on this and you can move like this. So you will get it. Okay. So tolerance is given for this 12 mm. The tolerance is positive tolerance. So go here and then fit with tolerance. So you can see the tolerance is appearing here. To control the tolerance decimal, it is of 3 decimals. So here you can go and select 3. For 12 there is no precision is required, so no decimal is required. So switch off the, this is for main dimension, this nominal or base size. This is for a tolerance. So for tolerance they controlled up to 3 decimals, so 0.027. Okay, so select here 0.027. Okay, this is 0, let it be. Okay, so again only see. So still what is left? So 45 we have to give the this we have to have a bend, we have to have a jog point, and also tolerance. Okay, first I will add the tolerance. So select this 45 and go and fit with tolerance. Okay, for this is, it is 45, so there is no decimal in that, so I will switch off that one, none. So I'll get only 45. For this one precision is up to 3. The values are 0.025. Okay, so go here 0.025. This one is 0. Okay. Yes. So now we have to have a jog point here. That means to bend that line, leaders. So again select this one. Okay. Go. So you have to have this symbol. Just move the mouse and wait until you get this symbol. Just right click, add jog. Okay. So now you can bend like this. Just click on that point, left click, hold the left click and move the mouse. Okay, so until you uh, keep the line perfectly, okay, as per the requirement. So we can reduce this tolerance size a little bit, this font size. So height is too big, so we'll reduce to 3. Okay. Hope I dimensioned all the entities in part 1. Okay, so the part 1 is completed. Next we'll move on to part 2. This is shaft. Okay, so I will go and bring in the shaft. See, while giving the dimension, this view dimension should not interfere with this one. Okay, so next so go to view layout, see, click model view. So now I'm going to bring in the shaft. Okay, shaft, open. So we will have the shaft here. So if I put it here, I will not have the space. Okay, so this view is not required. So how to get this different views? Okay, so after giving model view, so browse, so I'm bringing in the shaft. Okay, so just do the left click. So if you want the other side views, just move the mouse to your right, so automatically you will get the right side view, left side view, top, bottom. So just we want to move the mouse in that direction. Okay, so now I got this, just do the left click. So later once you bring all the views, required views, then later you can adjust the position. Okay, so I got these 2 views, escape. So in order to design any product, minimum 2 views are required. Okay, so single view is it is very difficult to design a product by having only a single view. At least minimum two views are required. Okay. So here I got this. So again, you can select this one and you can switch on the hidden parameters. So hidden lines. So this again go to annotation, smart dimension. This keyway length they have defined the keyway length. So it is 90. Okay. Then this chamfer distance also they mentioned. Okay. This chamfer distance, this one and this one. So it is 2. So try to keep close to this line. Okay. So it is automatically changing. Okay. So wait. Okay. So once you place and then you can move it. So while moving, it will not change the alignment. Okay. So it is given 2 into 45. Okay. So we can switch off the precision first. Okay. So this none. So now it's become 2. So you can add here 45. So you can add here, you can see degree symbol. So degree. Just drag it little bit to the right and then okay. So 90 also we will switch off the decimal parts. Okay. Still what things are left. So this whole diameter we have to give and then this keyway length. Okay. I'm going to move a little bit. So smart dimension. So whole diameter you can give. So it is coming radius. So select this, go to leaders, select this one, second one. So now it becomes diameter. They have given the they have given the precision. Okay. So select this 45. Go to value. So first I will switch off the precision for this decimal part. Then I'm going to have tolerance, fit with tolerance. Now you got positive and negative space for defining positive and negative tolerance. Go here 0.018. So here both are positive. Okay, 0.018, 0.002. Okay, so first one is 0.018. The second one is 0.002. So this one is not negative, so positive. So again, I have add a plus symbol here. So this precision decimal point you have to change. So automatically it changed. So for it changed for this base size also give none. So this you change to 3. Okay. So drag it. So we will add a jog point here. So select, go to leaders. So you can select this one. See, you can see multi jog leader. So select this one. So right click, add jog point. Okay. Select this point and you can adjust the line accordingly. Okay. Okay, now this font height is too high. Okay, I will reduce a little bit. Okay, this tolerance font size is high. Go to others. So switch off this both so that now you can have this option. 2.5 I'm giving. The jog point is gone. So again I will give a jog. So select leader, select jog. Add a jog point. Now it is fine. Okay. So this is done. Still this 39.5. So this distance, go to dimension, start from here to here. It is not coming, so I'll mark a center point here, center line. Okay. We'll try to smart dimension. It is not coming. So what you can do, sketch. So you can see point. So put a point here. Okay, now we have an entity there. So if you have entity that can give smart dimension, go to annotation, smart dimension. So it is coming from the center only. Okay, so I have to check it out. Now we can give from the base. So we can start from here, and I think now also it is coming only 17. So what we can do, so we can have a line here, try to have a line. So whether we'll check whether it is working, try to have a line like this. Now take smart dimension. Yeah, now it is working. Okay, just 39.5. Okay, so now we can give the tolerance level 39.5, tolerance of 0.2. So either you can keep inside or you can take it outside also. So go here, fit with tolerance. So the positive tolerance is 0.20. So the decimal for base size is 1. So I'm going to change it to 1. Whereas for this, it is up to 2, I think. So yeah, no, it is for this also it is 1. Okay. So you can see this size as this number is interfering with this dimension line. So we can go and change the font size others. So switch off this both this tolerance font size, select font size and give it as 2.5. So now you can get it within the line. You can either have like this or here like this also. So like this only it is given here. So they brought this outside. Okay. Okay, next thing is we have to give this 14. We have to define this and 14 again smart dimension. Go to annotation smart dimension and this one to this one is 14. Again this tolerance is given here 0.12 to 0.05. So switch on the tolerance. 0.122 to 0.05. So check the decimal digits, 3 decimal digits. So here you can see this is for controlling the decimal of tolerance. For the main, you don't need tolerance. Okay. So you don't need precision this decimal values for the base size, this 14. Okay. So you can reduce the size a bit. Okay. So switch off both this and select font height, give it 2.5. Okay, now we completed for 2 parts. I'll move on to this third one. Third one is a taper key. So bring in the taper, go view layout, model view, browse, bring in the taper key. So check it out. Yes. So this two. So I'm bringing this one to this side. Okay. just a bit. Okay. So now you can define this. Okay. Small annotation, small dimension. This one is 14. This one is 9. So for this also they have given the tolerance. This length they have given here 180. You have to place the this dimension at the center. Okay. So I have a note. So this is taper of 1 is to 100. Taper 1 is to 100. So here we will give the I will define the precision this tolerance 14 0 minus 0.043. Okay, switch on the tolerance 0, let it be 0 minus 0.043. 0.043. In the positive it is 0. Okay, so for 14 so we'll switch off the decimal part, whereas for this we will have up to 3 decimals. Okay, that's what given here. For 9 again there is no positive, only negative tolerance 0.09. Okay, so select this one, tolerance, so negative 0.090. So for this no decimals, this will have up to 3. Okay, yes, this clear. So if you want you can reduce the font size also a bit. Okay, this size also. In order to edit the font height, you have to switch off these two. Okay, then only you can edit the font. Now it is fine. So here 80 also we will remove the decimal part, just have only 80. Okay. Yes. Okay, so we got it. Next thing is fourth one is hexa bolt. So I'm bringing the hexa bolt, view layout, model view, browse. So hexa bolt. So wait, once again I will bring it. So next I will bring in the bolt and nut. So bolt, so you can go and check the alignment and come. Okay. You can delete this one. Select this one, delete. Can have only this. So it seems very big since it is in scale of 1 is to 1. So you can reduce the scale here. So you can 1 is to 2 you can give. So now the size is reduced. Okay. And try to move this here. Okay. So try to move a bit. so that we'll have more space, because we have to bring bill of material also within this. So we have to manage the space accordingly. So we can have this. So we can place this bolt here, because we need space to place bill of material. So we have to manage the space accordingly. So this one, what are the dimensions given? This 34 notation. This and this, it is 12. From this think we have to start from here. I think this to this. Should be, it should be 34. So we will override it. So here it is not coming correctly. I think I brought a wrong one, I think. So I want to bring it one more time. Model view, browse, size, flange coupling, hexa bolt. Delete this, not needed. So we have only this one. So this one, it is 8. Yes, this is the right part. Earlier I brought a wrong one, so this is 8. And then from here to here it is, yeah. So we'll give this one, this to this. This is 12. This is 34. Since we are having thread here, so it is not coming correctly. 34. So we can override this. Select this one. You can see we can override this value 34. 34. Then this thread length. This one. So this also again you can override. It is 18. Okay, you can switch off the precision, none. So here also it is none. This decimal digits you can switch off. So 12, for this they are given the tolerance. Okay, positive and both are negative tolerance, which goes up to 0.0242 0.006. Okay, so switch on fit with tolerance. Both are minus. So here you have to write minus 0.006. So here it is 0.00, I think 0.024. I'll check it once more. Yes. So now I will reduce the font size. It's too big. Switch off both this. 2.5. So still what is left here in this one? So here they have given it as M12. Okay, M12. So if possible we can mention that also. I will select these two lines. So it is coming 12, but they didn't mention as M12. So select this one. Okay, so you delete this dimensional everything. Okay, so you instead this I can have yum. So this precision you can switch off this decimal. So M12. Okay. Now still one part is left. So again view layout, model view. Go and bring in the exa nut. How they placed it? They placed it like this. Okay, so this one. So delete this one. So we need only one view. So select this. So I use the custom scale 1:2. Or you can, seems very small, you can have 1:1. Yes, 1:1 is fine. So you can switch on the hidden lines because the internal thread is there. We have to know that. So annotation, dimension, this is 10. So switch off the decimals. So you have 10. And then one more thing they mentioned is it is M12, but so we have a leader line and we will mention it. Okay. M12. Okay, now I gave dimension to all the parts involved in this assembly. Now I will bring the entire assembly. So we will display that entire assembly also here. Browse. So one, I think here I have the assembly. So I will bring the entire assembly. It's not visible. I think there is some problem. So again I will bring the here I didn't have this assembly, so here I have it. Parts are not visible. I faced a little issue while bringing the entire assembly. Now I rectified it because I designed it twice. Okay, so that's the problem. So now I rectified it. Browse. Now I'll bring the assembly. So here also I'll get, but we will place it in isometric view like this. So I'm this. If you grow in this direction, if you go in this direction, you'll get this kind of isometric view. So I will keep this one. I will delete this one. One assembly thing is enough. Okay, so you can have here. So select this one and change to solid. Okay, change to solid. This if you want you can this is 1:4 5. So if you will have 1:4, so a little bit big, or 1:3 also I'll check. So no, it is a little bit, it is intersecting with the sketches, or if I try to move this one, I'll see any space is there. Okay, that's fine. So I will keep it 1:3.5, a little bit. Yes, this one. Now this one is fine. Now I will put the bill of materials. Annotation, you can see, go to annotation, you can see the tables. Okay, select this tables, put bill of materials. So I want to this bill of material for this one. Okay, So this assembly, don't put part by part. So you select the bill of material for this complete assembly, select OK. So you'll get a this, bill of material. So adjust the column size, just keep the mouse at the center so you can adjust it and reduce the column sizes. So automatically the quantity will come. So based on the number of components involved, so you can see the quantity also here. You can check 44222. So the same is available here. Okay, in the description box you can have the material name of the material used for each component. It is iron 410W. So the same you can have. For flange they used CI cast iron. So the same you can have. So double click on this. So it will ask you to keep the link or break the link. So you break the link. So this is FE410W. So again double click here. Again it will ask break the link. FE410W. I have to double click. Okay. So every time it will ask you to break the link. 410W. The first flange is cast iron. So CI. Now fine, if you want you can reduce this a bit. Okay, now this is our bill of material. So you can add the title also here. So for adding the title, so right click, edit sheet format. Okay, so here you can have this note here, flange coupling. So a little bit I will increase the this font size. It's 13. Take it 40. Now after so I will bold this also. Okay, now come out of the sketch. Okay. So this is the final output. You can save it. So if you have any doubts, you can put it in the comment section. So I will reply you. Thanks. So I will come with another video.